Hey everybody, we are going to work on our next topic, and our next topic happens to be the 11.2.1 Introduction to Single Variable Polynomials. And then we're going to do the next one, the 11.3.1 Simplifying and Evaluating Polynomials with More Than One Term. So why don't you have those notes ready, and then I'm going to share my iPad screen. Okay, I'm sorry, I'm just kind of rearranging things here. Okay, so hi everybody. In this video, we are going to go through 11.2.1 Introduction to Single Variable Polynomials. We are also going to go through 11.3.1, which is simplifying and evaluating polynomials with more than one term. So make sure you have those notes ready, and then we're just going to get started. So the first one, we have our definition of a polynomial. Oh, don't have my pen tool turned on. Okay. So we have our definition of a polynomial. And a polynomial is going to be an expression that can have constants, variables, and whole number exponents. The constants, variables, and exponents can be combined using mathematical operations. So a polynomial cannot have any of the following. So it can't have division by a variable. So what that means is you can't have a variable in the denominator. So like we can't have something like 2 over x, right? So if I said, is this expression 2 over x, is this a polynomial? The answer to that would be no, because you can't have a variable in the denominator. If I gave you something like this, though, x over 2, yes, that's fine. There's no x in the denominator, no variable in the denominator. The next bullet is saying essentially the same thing. It says you cannot have negative exponents on a variable. It's totally fine to have a negative exponent on a number or a coefficient, but not the variable. So for example, if I said 2x to the negative first, that's exactly what the example was showing in the previous bullet, right? So that would be like 2 over x. It's the same thing. However, you can have something like this. So if you had 2 to the negative 1x, that's totally fine because the negative 1 exponent is on the 2, not on the x. So this one would also be 1/2 x, and that's okay. That would be considered a polynomial. That would actually be called a monomial. You also just can't have an infinite amount of terms. And so we don't really see those situations in this class, but that's another scenario that a polynomial cannot be. We also talk about different types of polynomials. One polynomial with exactly one term is called a monomial. So look at your prefixes here to help you. So mono is going to be, 1, bi is 2, tri is 3. And so our examples of that could be like negative 3x squared. That could be a monomial. We could have just the constant term number 5. That could be a monomial. So anything where it's just a single term is a monomial. A binomial is exactly 2 terms. So it could be like negative 3x squared plus 5. That would be a binomial. We could say 2 plus 3. That's a binomial. When you combine them, though, that would be a monomial. The trinomial is a polynomial with exactly 3 terms. And so a trinomial could be like negative 3x squared plus 2x plus 5, where we have exactly 3 terms. We could also have 2 plus 1 plus 2. to give us our trinomial. The other thing that EdReady is going to ask for is the degree of your polynomial. The degree of your polynomial, by definition, it's going to be the same as the degree of the term with the highest degree contained within a polynomial. And you determine the degree of each term in a polynomial by adding the exponents of all of the variables contained in a single term. So it's kind of a weird rule, and honestly, the why behind it, or why this is even useful, you wouldn't really use until calculus class. So here we're just kind of identifying what's the degree of this polynomial. So for example, if I've got a term and I give you this and it says -1/2 x to the third y squared. So again, not the definition, the directions, that's the word I'm looking for. The directions here say determine the degree of each term. Or go back to your process, it's right there for you. So the degree of the polynomial is going to be the same as the degree of the term with the highest degree contained within a polynomial. So that means what we're doing is we're looking at the degrees of each of the terms in the polynomial, and whichever term has the highest degree, that's also going to be the degree of your polynomial. Well, in order to even figure out the degree of a single term, we look at the exponents in a single term and we add them up. And so this particular monomial is a 5th degree monomial because it's a single term and the degree of this one term is 5th degree. So if I gave you another example of 3 squared, a b to the 4th c squared, and again, you're only looking at here, if you look back in your definition, you're only looking at the exponents on the variables. I don't care about the numbers for this to find the degree. We're just looking at the degree or the exponents on our variables. So here we've got 1 plus a 4 plus a 2. Again, we don't care about that one because it's on our coefficient here. We're only caring about the exponents on our variables. So here we've got a 7th degree monomial. All right. How about if I just said -10? What is the degree for just that constant term? And so I'd pause it and think about it. Like, the question you should be asking yourself is, what is the variable in this example? And we don't have one, right? So let's say we wrote one on there and I wrote it like that. What does x to the 0 actually mean? And I'm hoping you say 1. So x to the 0 actually means 1, which would be -10 times 1, which gives us back -10. So is this okay for me to write that on there? Yeah, because we get back exactly what we started with, which was -10. So now looking at this, what's the degree of my term that I started with? So I started with this. What's the degree of this monomial? It's 0. So this would be considered a 0 degree monomial for that one. All right, so I'm hoping you've noticed all of these have been monomials. We're going to look at some different types of polynomials on the next page. So in this table, we're going to fill in some different examples. The first one I want you to fill in is going to be -x squared over 4 plus 3x minus 1/2. And you should ask yourself, is this a polynomial or not? And how you determine that is look back again at this list up here, what a polynomial cannot be. Okay, so we can't have division by a variable and we can't have a negative exponent on our variable. Do we have an x anywhere in our denominator? No. Do we have a negative exponent on any of our variables? No. So is this a polynomial? Yes. So this will be a polynomial. If so, what type? Is it a monomial, binomial, trinomial, or other? We're counting up your terms. So you've got 1, 2, 3 terms here. So this is a trinomial. If so, what's the degree? So the degree of just this first term, You're looking at the exponents on this first term, it's just 2. So there's a second degree term here. We've got a first degree term. And here with the constant, we've got a 0 degree. And so we look at each of the terms individually, which one has the highest power, the highest degree, and it's this first term. So again, go back looking at, and I'm just kind of repeating this definition right here, the degree of our polynomial is going to be the same degree as the term with the highest degree, and that's this one. So here we've got a second degree polynomial, and now we're going to name it. So now we're going to say it's a second degree trinomial for that one. All right, next one. Next one we're going to look at is negative mn squared. So is this a polynomial? So you should pause this and see if you can get this example right all by yourself. So is it a polynomial? It should be yes, because we don't have any variables in the denominator. We don't have any negatives on the exponents on those variables. So this is a yes. How many terms do we have? We have 1, so it's a monomial. What's the degree? So here, the implied exponent on the m is a 1. We've got a 1 and a 2, which means this is a third degree. So this is going to be a third degree polynomial, and specifically it's a third degree. What type is it? How many terms do we have? It's a monomial. So third degree monomial. Next example, we're going to try, this one's kind of long. We're going to do 8, you're going to have to write small. 8s squared t minus 4s squared t squared plus, sorry, I'm going to go right into that box, 2st to the third plus 9. So that's your total monomial, or not monomial, polynomial there. And you should ask yourself, is this a polynomial or not? Yes, it is. There's no variables in the denominator. We don't have any negatives on any of the exponents. So this is yes. How many terms do we have? We've got 1, 2, 3, 4. So we've got 4. There's not a number, there's not a type that we call for a fourth degree polynomial. So we just say other. And it's going to be here looking at your degree. So here are degrees up here. We've got 2 and 1. So this is 3. Here we've got 2 and 2. So this is going to be a fourth degree. Let me write in a different color. So this is 3. This is 4. Over here we've got 3 and a 1. So this is another fourth degree term. And then a 0 degree here. So which term has the highest degree? It's the fourth degree. So we're going to write fourth. And then it's just going to be a fourth degree polynomial. All right. I'm going to give you one more, and then I'm going to give you some to try on your own. So this next one I want you to try, we're going to do together, is going to be x squared minus 1 over x minus 3. I want you guys to go ahead and start working on that one while I write in the other examples that I'm going to have you guys try. Okay, so the next one here, is it a polynomial? I'm hoping you said no, because you can't have an x in the denominator. And so this would be no, and then you're going to explain why. So that's right here, or explain why it's not a polynomial. No, because you can't have a variable, and I'm going to come up here, because otherwise I'm going to run out of space. A variable in the denominator. So that would be a reason why. The other one I want to look at with you is the very last one. So this very last one, I'm going to urge you to see if you can rewrite it somehow. So here we could say, well, maybe this is like a negative a b to the fourth because we're adding up those exponents. And then we've got plus 5 to the negative 1. That's also the same as 1/5, right? So 5 to the negative 1 is the same as 1/5. Just don't let that confuse you there. And then you've got b to the fourth c squared. So look at all of the exponents on the variables. Again, we don't care about them on the coefficients. Are they all positive? Yes. We don't have any variables in the denominator. So this is going to be a polynomial. What's the degree? So if we're looking at the degree, we've got 4 and 1 here. So this term's going to be a 5th degree. And then here we've got 4, 5, 6. So that's a 6th degree. So that means, oh, and I'm jumping boxes here. So that's 6th degree. What type is it? So sorry about that, I skipped a box. What type is it? We've got 2 terms. So it's going to be a binomial. And then finally, for naming it, it's going to be a 6th degree binomial. So on those other ones, those 3 examples in there, I want you guys to try those on your own. And I'm making note of that so I don't forget. All right, so now we're going to look at evaluating polynomials. So evaluating polynomials, what we do, it says directions, substitute the values for the corresponding variables every time they appear. So I'm going to give you a polynomial, and our polynomial is going to be 12k squared minus 9k to the 5th. And I want you to evaluate that. So the directions are evaluate the polynomial when ... and now you're going to have 3 different scenarios. When A, k equals -1, B, k equals 2, or C, not or, but it should be and C, when k equals -3. So I want you to plug those in, and we're going to see what you get here. So I'm going to do the first one with you. We're going to have 12 times -1 quantity squared minus 9 times -1, and we're raising that -1, that quantity of -1 to the 5th power. So here we've got 12. This -1 times -1 gives us a +1. And then we've got -9, and then -1 to the 5th, because we're raising it to an odd power, so it's going to be negative. So this is going to be -1. I'm going to come up here. So then we've got 12, and then here I'm looking at the fact if we multiply these together, we've got minus 9 times a -1 is going to be a -9. Minus a negative is going to give us a positive. And then we're going to get 21 for our answer for that one. So then what I would like for you guys to do, I'd like you guys to try these. So try those 2 and see how you do. The answer for this one, when you try it, you should be getting -240. If you're not, ask me. I'd be happy to go through that one with you guys. On C, when you go through it, you should be getting 2,295 for that one. And if you're not getting it, again, let me know and I'd be happy to go through it. Okay, for our next example, this is example 2. We are going to have -2/3 y squared plus 2y minus 4. And we're going to evaluate it when, so this is part A. Evaluate it when y equals -3. And then B is going to be when y equals 6. So we're going to plug those in. So we've got -2/3 times -3 quantity squared plus 2 times the -3 minus 4. So then we've got -2/3 -3 times -3 should give you a +9 here. I'm going to put it over 1 because I know I'm getting ready to multiply fractions. And then in the next one, I'm going to multiply these together. So 2 times the -3 is going to give me a -6. It's up to you. I normally write -6. Some people like to write plus a -6. If you want to do that, I don't care. That's fine. I'm just going to write -6, -4. All right, next thing. You can think about what is 2/3 of 9, because that's what this next thing is. What's 2/3 of 9? Or you can just multiply straight across. If we multiply straight across here for this fraction, it's going to be -18 over 3. -18 over 3 is going to give you -6, right? So -18 over 3, when you reduce that, just gives you -6. So that's how I'm getting this -6 right here. -6 -4. And then you should be getting -16 from that. So you're -16, you're getting the -6 minus 6 is -12. -12 minus 4 is going to give you a -16. Okay. So let's try the next one. So the next one is we've got -2/3 times 6 squared plus 2 times 6 minus 4. So here we're going to do -2/3. 6 times 6 is 36 all over 1. Plus 12 minus 4. So I'm going to do a little reducing. This is going to be a 1. This is going to be a 12. And now I've got -2. Now I've got -2 times 12 plus 12 minus 4. So this is going to give me a -24 plus a 12 minus a 4. -12 plus a 12 is going to give me a -12 minus a 4 is going to get me right back to where I was on the first problem or the previous problem, which was -16. We're going to try one more. You guys need to write smaller than me because otherwise you're going to be way out of space. All right, here we go. So this is example 3. And this is given 4a squared b minus 2ab squared plus a minus 4. And you are supposed to evaluate that expression when a equals -1 and b equals 2. Also when a equals 2 and b equals -3. And then the last scenario will be, so this is A, this is B, this is C. The last scenario will be when A equals -3 and B equals -2. So those are the 3 we're going to try. So the first one, we're going to have 4 times -1 quantity squared times a +2 minus 2 times a -1 times a 2 squared plus 9 minus 4. So that -1 quantity squared is going to give us a +1 times a 2. I'm already looking at the fact that we've got a negative and a negative, which is going to give us a positive here. And then 2 times that 1 is going to give us a 2. 2 squared is going to give us a 4. And then we've got plus 9 minus 4. So we can just write plus 5 at the end. So 9 minus 4 is going to give us 5. All right, the next part of it, 4 times 1 times 2 is going to give us 8 plus 8 plus 5. So 8 plus 8 plus 5, is that a plus 9? Okay, no, we're doing good. So 8 plus 8 is going to give us 16 plus a 5 is going to give us a 21. I know what happened here, and it's fine. You can just keep writing it how I did it. I think when I wrote down the problem, I said that was an A, but in this problem, I read my own sloppy handwriting as a 9 instead of an A. So that's what happened. So if you keep this as a 9, everything is fine. if you keep that as an A, what you should have plugged in there was a -1 in there. And if you did that instead, so if on yours you put an A right here instead of a 9, then your answer should come out to 11. And it's totally fine. You can write whichever one you want to. But I just wanted to let you know, if you actually wrote in the -1 in there in for the A, you should get 11. If you did what I did and you misread my own handwriting and wrote a 9 there, then you should get 21. And that looks good. Okay. So the next one, I'm actually going to read this as an A rather than a 9. Okay, so then we've got, for this next one, we've got 4 times 2 squared times the -3 minus 2 times the 2 times the -3 quantity squared. This time it's not going to be plus 9, it's going to be plus 2 minus 4. So that you should have it set up like that. I want you to finish filling in, like follow all of your steps, go through your order of operations, keep simplifying it. And on that one, you should end up getting -86 for that one. So I want you to keep following your steps, doing your process, so it's all complete for your notes check. Then on this one, on letter C, I want you to try that one on your own too. And when you're done with that one, you should be getting a -55 for that one. And if you have questions on it, be sure to ask me. And other than that, that's all we're going to do for this video.